Students, in continuation with the message authentication algorithm, let us see the hash function of it. So hash function is generally like MAC. So it contains an arbitrary message to a fixed size, which is represented here is H equal to capital H M. So here the hash function is public and it is not keyed. And hash is used to detect the changes to the message and can use in various ways with message. And it also most often to create a digital signature. So let us see with this block diagram. So this represents it's only hash code is encrypted using a public key encryption, and also by using a sender's private key, it is authentication and it provides a digital signature. So these are the requirement of hash function. It can be applied to any size message and produce a fixed length output, and it is easy to compute a H equal to capital HM for any message M. So given H is invisible to find, and also it is invisible to find Hy of Hx, and it is invisible to find any x in y. So simple hash function. So simple hash function is something that has several proposals for simple function based on XOR of the message blocks, which means it divides the message into equal size of the blocks. It also perform XOR operation block by block, and also finally output is hashed. So here the operation performed is XOR operation, that is very secure and it needs a stronger encrypted cryptographic function. So let us see about the secure hash function and MAC. So attacks on hash function and MACs are basically of two categories. One is your brute force attack and cryptanalysis. So let us see detail about the brute force attack. So hash function. In hash function there are three desirable properties. So the main thing is one way, that is for any given code H, it is computationally infeasible to find X, which is said to be Hx equal to small h, and weak collision resistance, which means for any given block X, it is computationally infeasible to find y is not equal to x. And the last one is strong collision resistance. It is computationally infeasible to find any pair which is x comma y. So the last one is for a hash code of length, the level of effort is required, as we have seen, is proportional to the following. So here one way is 2 power n, and weak collision reference is 2 power n, and strong collision resistance is something that 2 power n by 2. So next is, let us see about method message authentication code. So in your brute force attack, a MAC is more difficult undertaking because it requires known message MAC pairs. So let us see something that to attack a hash code, we can proceed by the following bits. So it is an example. So here they are having a fixed message of x with n bit hash code. So here by using this brute force method, they are finding the collision to pick the random bit string, that is said to be y. So check if h of y equal to h of x. The attacker can do this repeatedly offline. So whether the offline attack can be used on MAC algorithm depends upon the size of the key. So if the attacker determines the MAC key, then it is possible to generate a valid MAC value for any input x. Suppose the key size is k bits, then the attacker has one known text MAC pair, then the attackers can compute n bit of MAC, and it is also known text for all possible keys. So at least one key is guaranteed to produce a correct MAC. So this phase of attacks takes an effort proportional to 2 power k. So next is cryptanalysis. So cryptanalysis is something that cryptanalytic attack on hash function and MAC algorithm seek to exploit some properties of algorithm to perform some attack. So the way to measure the resistance of hash and also to cryptanalysis is to compare its strength to the effort required for a brute force attack. So here an ideal hash or a MAC algorithm will require a cryptanalysis effort which is greater than or equal to the brute force effort. So here cryptanalysis, you have a hash function and message authentication code. So the hash function takes an input message partition into L fixed size block of B bits each. Then if necessary, the final blocks is padded to B bits. So the final block is also included the total length of the input to the hash function. So next is your message authentication code. So here is something that there is a variety of structure of max than in hash function, and it is difficult to generalize about the cryptanalysis of max. Let us see about the message digest. It is something that a fingerprint or summary of the message, and it is also used to verify the integrity of data. Example, LRC parity checking. Next is idea of the message digest. Calculate the message digest of 7391743. This is an example. Here we have to multiply each digit in the number with the next digit, it is excluding if it is 0. And disregarding the first digit of the multiplication operation, it is result to 2-digit number. So this is which we will do in digital electronics. So here in this number example which is given, how it is calculated. So multiply 7 by 3, that will be 21, and discard the first digit, the answer, the balance digit will be 1. So again multiply 1 into 9, the output will be 9, and 9 by 1, the again will be 9. So next is multiply 9 into 7. So 9 into 7 is 63, omitting the first number, then you will be having 3. So 3 into 4, that will be 12, and omitting the first number you will be having 2, and for last is 2 into 3 will be 6. So the message digest is 6. So I think this example will be clear about this topic. If you have any clarification related to this topic, feel free to contact me. Thank you.